So up to the last class, do you have any doubt, anyone? So now we have sufficient number, so we can start. So now jokes apart, so we'll be starting with this thing. Okay. So do you have any doubt after the last class? Any question that you want to ask me?
No, sir.
Okay. So in the last class, what we have discussed, do you recall? So what are the things that we have discussed? So we're discussing about all those sheet metal operations. They are in the last class basically about the different sheet metal operations like blanking, piercing, etc. Those things we have discussed in detail. Apart from that, other sheet metal operations like all the slitting, like saving, nibbling. Okay, so that kind of different other operations apart from blanking and piercing. Those things we have discussed. There in the last class we have also have seen how we can how they are the blanking and piercing, how they are similar and how they are different also. Okay, so our you can say which particular part becomes the workpiece, which particular becomes scrap in case of this particular type of sheet metal operation. So those things already we have discussed, and you should be very you should be able to distinguish them. And what are the type of forces that is involved, those things also we already know. Okay, and we also have discussed about the sizes of die and punch, etc. in case of blanking and piercing. So today we'll be solving a very small problem regarding the requirement of all those like whatever the expression we have seen for all those punching or like simple force, similarly stripping force, etc. All those things also we have discussed in the previous class. Why stripper is required, what is the force involved, how to calculate it, and all. So today we'll be solving a small problem with respect to that. Okay. So now we'll be going through this particular question. So what is the question? Question states that you have to determine the diameter, the die and punch sizes for blanking a circular disc of 20 millimeter diameter from a C20 sheet metal whose thickness is given as 1.5 millimeter. Also, you have to calculate the punching and the stripping force required. So, some given data it is given that the shear force or shear strength of C20 steel is it is 294 megapascal, and stripping constant for this particular case is 0.024. So, once you go through this particular questions, immediately it will stick to your mind. That means strike to your mind. That means we basically have to find out the die and punch sizes. And what is the operation? Operation is basically you have to blank out a circular disc, and size of the blank is given. Okay, shape is circular, no problem. We are not that will be required circular. Which kind of shape is that? Okay, and the size is also given as 20 millimeter diameter. Okay, and the material is given, its thickness is given. So initially we have to find out write down all the given data. So here we are writing all those given data. So first thing is like already 20 millimeter diameter that is given, so this is we can consider D. Okay, so thickness is given as 1.5 millimeter. So thickness which small t we are denoting 1.5 millimeter, and material shear strength that is given as 294 megapascal, 294 megapascal, and stripping constant for this case K equal to 0.024. Those things are already given. Okay, and apart from that, our important thing to notice will be we are talking about blanking a circular disc. Okay, so that will be required, and ultimately the sizes of the die as well as punch size that we have to consider for a particular operation. Okay, so now how to find it? So now if you see basically we're mostly interested in finding out one of the thing is like the punching and the stripping force, etc. also will be required, and apart from that the sizes are required. So with respect to the size, we already know how we provide the if it is a blanking operation, what how the blank size and the die size they are related, or if it is punching, how they are related, etc., etc. Okay, so punch size, die size. So considering those, we have to solve it. Apart from that, as we have to find out the punching and stripping force, so the already known expression we already have. So in that particular expression, whatever is unknown, whatever will be required, those things we need to find out. Okay, so if we're talking about all those blanking operation or considering maybe the piercing operation also, we already know how they are related, so those things we'll be considering. Okay, and prior to that, as will be the clearance requirement of the clearance. Okay, it is already there, and the finding out the clearance value will be required so as to obtain whatever is the die size, punch size, etc. Okay, so initially we'll be finding out the clearance. This is clearance per site. Okay, so this is the clearance per site. Okay, so sorry about this. Okay, per writing in laptop it's difficult. This clearance per side. Okay, so how to get it? So for this we already have c equal to 0.0032 into the thickness into the tau. Okay, so in that particular case already we know that what are the unit that we have to use. Already we have discussed, if you can recall from the previous classes. So for using this import like expression. Okay, so we have to have the unit. You have to use the unit in this proper unit. Okay, proper form. So now in that particular case, considering the unit system, so one it is 0.0032. There is no problem with that. It is in millimeter, so you want in millimeter. Okay, so it has to be considered like that, and root over tau. So already we know, if we are talking of megapascal, so megapascal itself is nothing but in Newton per mm square, and we require in megapascal or Newton per mm square is the same thing. Okay, so that is the thing. So we're considering like that. Okay, if sometimes it is not given in megapascal, okay, then you have to convert it to megapascal so as to use this particular formula. You have to be careful with the units. So after finding out, so we are getting it 0.082, and it is approximately zero point 0.1 millimeter. So you can directly use this value also, and maybe uh, you can approximate it to zero point 0.1 millimeter also, no problem. So if you do that, the calculation will be somewhat easy. Will next, clearance per site we have obtained by using the standard formula. Now what we are going to do, we are considering both blanking operation, we are considering like piercing operation also. So in both the cases we'll be basically solving it. Okay, if it is blanking operation, in blanking what will happen, in piercing what will happen. Now in case of blanking, we already know, so even if it is blanking or even it is piercing, we already know that we have to have a particular die, okay, of a particular shape, and we have this particular sponge, don't mind my drawing, and we have clearance between them. Okay, so this was clearance on site. Okay, similarly here also we have got this particular clearance. Okay, if I consider this, okay, so basically this is clearance in one side, this is clearance in another side. Okay, so we know that basically the punch size, if it is punch, okay, this is the die. Okay, so generally this we have the clearance between them. Okay, now if it is blanking operation, how they are related. Now in case of blanking operation, the die size itself is equal to the blank size. Okay, so this die size, this is the die size. Okay, so die size itself is equal to the blank size that we are going to get if it is blanking operation. Okay, and considering that already the blank size is already given, diameter of the blank is 20 mm dia. So in that particular case, die size itself is equal to blank size itself is equal to 20 millimeter. And what about the punch size? In case of blanking operation, punch size definitely is equal to this blank size, this is minus twice of the clearance. So clearance, this is per side. Okay, so in both the sides there will be clearance. So if this is the punch, okay, if we consider the clearance, so it will be minus 2c, so as to get this particular punch size. So punch size equal to blank size minus 2c, and considering the approximated value of 0.1 millimeter, so we are going to get it 20 minus this 2 into 0.1, approximately this value. Okay, next, if we consider, or if it is a piercing case, okay, in case of piercing what will happen, so in case of piercing, the punch size is equal to the blank size. Okay, so whatever blank that you have to punch it out. Okay, if it is piercing operation or the punching operation, punch size itself is equal to the blank size. So in that case, in our case, it will be equal to 20 millimeter. And what about now we have the punch size in case of piercing, that is our initial. Okay, we know punch size equal to die size, blank size, sorry. So now how to get the punch die size? So die size will be this punch size plus this mass plus this mass. Yes, so that we will get this particular value of the die. Okay, so that means die size equal to blank size plus twice of this particular clearance per side. So that will give you, if we use the approximate value of 0.1, So it is going to give us 20.2 millimeter. Okay, up to this much everyone clear? How they are related in case of planking operation and in case of piercing operation, die size and punch size. Let me know. Yes or no? Okay, thank you. So our problem, first part of the problem is over. We have found out the die size and the punch size if it is considering both the cases of punching as well as blanking operation. Okay, now the second part is we have to find out the pierce punching force as well as the stripping force. So for that also we already have the standard expression. Okay, so punching force P is given by L into T into the tau. Okay, and once again we have to be careful while using these two formulae. Okay, we have to use the proper unit system as already previously discussed. So now how to get it? So L, what was that L? It was the perimeter of cut. It is not like length or arm. Okay, so it was the perimeter of the cut. So now, yes, it is. We are talking of a circular disc, circular plane. So perimeter, how to find out perimeter? It is pi d or 2 pi r. Okay, that gives us the perimeter of cut. So we already know if it is a circle, if it is a circle, don't mind my drawing. It's difficult to draw in laptop. So if it is a circle, so this perimeter is given by this expression pi into d or twice pi r. Okay, and we already have the pi is pi, and already d is already given as 20. So L is this mass millimeter 62.5. 62.83 millimeter, so that we can use, and thickness already is given, material shear strength is already given, so we can get the answer. Okay, so if you can recall, so now if we use this formula and this unit system, tau in megapascal, L in millimeter, T in millimeter, then we get the punching force in Newton. So that has to be, you have to be careful with that. So that's why it is in Newton. Initially it's Newton, and if we convert it to kilonewton, then it will be 27.708.8 Newton. Okay, so it will be kilonewton. Sorry. So now that is about punching force. Also for stripping force, we already have this expression. So K into L into T, where K is the stripping constant. So that is already given. L already just now we have found out, and thickness is also given. Okay, and find using this in this particular mode, and what we have seen. So if we use L in millimeter, T in millimeter, and the stripping constant as it is, okay. So in that case, we are going to get the stripping force is kilonewton. So that's why here directly it is in kilonewton. Okay, so this completes this problem, which is a very easy one. But the thing is, you should know this expression and the proper unit system. Similarly, in case of piercing and in case of blanking operation, how the die size, punch size, they are related with respect to the blank size. Okay, if you know that much, you can very easily solve this problem. So just let me know whether you have understood or not, or if there is any confusion, you can ask. Yes, all of you have understood this problem, right? You can do this kind of, you will be able to solve this kind of similar kind of problems if someone asks you. Okay, thank you. So now we'll be going for the next topic, that is basically about shear, effect of shear on punch. So this particular topic is very easy only. We sometimes provide some shear on the punch so as to get proper shearing action, and already in the note also I have given you the this particular note. So I want that you should go through this particular note as well as some other books, or you consult with that, okay, and find out what is the effect of shear that is given on the punch. So basically, it is to reduce the required shearing force on the punch. Okay. Basically, we ground the face of the die or the punch. Okay. Shear is grounded on the face of the die or the punch. Okay. What is our intention is basically to reduce the required shearing force. Okay, but the total, you must remember that after providing proper shear to the punch or die, okay, effective shear. So basically the total work that has to be done in this particular work, Okay, the shearing action will be the same, but the maximum force, okay, the amount of the maximum force, okay, whatever you have to encounter, that becomes less, so that some less powered instrument also you'll be able to use, but ultimately the work done has to be same. Understood? So that is basically what we can have concave shear, we can have some balance shear. See, you can, we have ground shear here, and this is kind a case of unbalanced shear. So go through it. Okay, it's very easy thing only. So this different operation, by this time, as we have already discussed uh, different operation. Okay, we already have the idea, so that's why we'll be able to go fast. So next is drawing operation. Okay, so drawing operation is what, basically it's a process of making cups, okay, sheets and similar articles from metal blank. So metal blank, we are talking about the sheet metal blank only. Okay, and from there, by drawing operation, basically we obtain some cell like or cup like structure. Okay, so this kind of product that we have. So now in this particular drawing operation, basically we encounter two words. One is the, we use the shallow drawing, and the word that is the deep drawing. So how we can define shallow drawing and deep drawing? Basically, when the depth of the product. So here in this particular figure, you can see three different stages of deformation of the work in case of deep drawing process. So now when the depth of the product is less than the diameter of it, okay, or the smallest dimension of its the opening, then we consider it as a shallow drawing, which is somewhat easy to perform. Now, whenever the depth it becomes greater than that of the diameter, okay, where with depth we are basically talking about this particular length, okay. So then basically it becomes a deep drawing operation. So how basically we perform the deep drawing? So once again we will have the die and the punch, and die is generally is the lower one, okay, and it is fixed generally, and punch, with the punch we provide the required force. Okay, so now in that particular case we'll have this particular, if you look at this particular figure, the blue part, okay, it's nothing but we are considering as the sheet metal, and it has to be clamped properly. This shows the clamping, so this is the clamping force that we are seeing. And after that, it is in this particular figure, it shows the initial contact that we are going to make through the, by the help of this particular punch. And generally what happens in this particular drawing operation, it's important to provide this radius in this particular die, okay, so as to allow smooth movement of this particular sheet metal in this way, okay, so that our ultimate intention is we want to get a cup like structure. That is what is the drawing operation. So in this out of the five stages that we are saying, so first stage is, first figure, it shows just before the contact, okay, and the second figure, if you look at, where basically what happens, a bending like when bending happens in this particular zone, okay, so as it is moving downward, the punch is moving downward, it is forcing the, this particular, it is stretching this particular sheet metal, and it is along with this particular contact of this particular punch, okay, it is coming down, and here basically it bends at this particular zone, and this whatever radius that we provide in this particular die, it facilitates the easy bending, okay, easily it bends. So here and here it shows the bending at these two zones. One is with respect to this particular die, and one is with respect to this portion of this particular the punch, okay. Next option is basically straightening. So straightening means what, still when it is still further going downwards, this punch is further going downwards, so basically this portion which is along the side wall of this particular die, it gets straightened, okay. And once again after that, once again it is going to it is further going downwards, and some friction and compression kind of thing it will happening here, okay. And at the end, basically the final cup shape we are going to obtain once the whole material has come down like this, okay. So then we are going to, this is the final cut part, okay. So this is basically about our like this particular drawing operation, okay. So here also is a similar kind of thing that has been shown, so fans, and sometimes we also produce, give some air vent, okay, and so that uh, sticking of this particular, you can say, pans and this particular workpiece, okay, it's not there. So this is basically about your drawing operations, and we can have deep drawing as well as shallow drawing. Similarly, there is another operation known as the ironing. So basically, what is ironing? Sometimes it is discussed, sometimes it is not discussed as another operation. Basically, in the ironing operation, the what happens basically, thinning of this particular side wall from the workpiece, which you can see if this is the workpiece, then this shows the thick, it is somewhat thicker. Okay, in this particular portion it is somewhat thicker. So basically in the ironing process, it is the operation of thinning the side walls, and in that particular process height gets increased. So actually this particular thinning happens here. Okay, and height also will increase. And once again here also we have to go for a particular die and punch set. Okay, and it's somewhat similar to drawing operation, but the thing is the clearance between the die and the punch, it is smaller than that is used in the drawing operation. And this smaller level of basically clearance, it facilitates thi- thinning of this wall. Okay, in between that, that means wall, like walls of this particular die and the punch, basically thinning happens. Thin, the material gets thin. Okay, and if when it gets thin, okay, movement of the flow of material will be there, and the height gets increased. Okay, so that is what is the, and its wall thickness can be reduced up to as much as 50% in a single ironing operation. Understood? Up to this much, what is drawing operation, what is ironing operation? Yes or no? Let me know. These are easy process only, small processes. Similarly, we can have different processes like embossing, coining, etc. Those things are already given in the notes also. We'll just discuss and you also go through it. And we have bending operation of sheet metal, which is also like frequently performed. But whenever we are talking of this particular welding process, basically you should be, while you are doing the bending, you should be careful about the direction of the bending. Okay. So what we have to do is, if you look at these two figures, so this is a transverse bending product and this is a longitudinal bend product. So if you compare both of them, the look, it may look somewhat similar, but actually the transverse bends, gives us poor performance, or it is not good. Always you go for longitudinal bends. So always the bends, it should be made with the bend axis perpendicular to the rolling direction. If previously the metal has been rolled, okay, the workpiece has been rolled, and rolling direction, you know, okay, based on that. So have to be careful while selecting the bend axis. Okay, and whenever you are making some intersecting bends, then both should be at an angle to the rolling direction. Okay, so that is basically about bending operation. So in bending, basically that means we are basically bending the sheet metals. Okay, which is very frequently it is this kind of processes are also being discussed. Okay, so we can just go through it, no problem. Next, we'll be discussing about spinning operation. Now, what is the spinning operation? Now, the spinning operation, it's a process which is used for making cup-shaped articles, and the main thing is there the products are axisymmetrical. Okay, axisymmetrical means about a particular axis it is symmetrical. So that kind of product, it can be, or that kind of cup shape kind of product, it can be obtained by the spinning process. Okay, now what are the stages, or how we perform this particular spinning operation? Now basically what happens, this process of spinning, it consists of rotating the blank is nothing but the kind of workpiece, that is a sheet metal workpiece we are talking about. Okay, and this blank is generally fixed against a form block. What is form block? Form block means that particular, it's acting like a kind of the die kind of thing. Okay, so ultimately what happens, whatever is the final shape requirement, which is basically axisymmetric. So if you look at this particular figure, so we have this blank here. Okay, which is being called like this. Okay, and now it is basically fixed against this form block. This particular block, actually it has got a particular shape. So it's basically is kind of, it resembles the our final required shape. Okay, it's generally is a solid kind of thing, or maybe this particular surface will have the in between, it may be hollow, there is no problem with that. And basically what happens, if you look at, so the product, okay, this particular form block also you can say, or ultimately the product, it's basically about this axis. If you look, okay, it's axisymmetric. So if you rotate this, that means, and what we'll do, we'll see. So now, as why this word is known as spinning, basically you'll see that this form block has been spun, okay, and we do the process. Now in that particular process, okay, the process of spinning, it consists of rotating the blank, okay, and which is fixed against the form block, and then we apply gradually moving force. This is important. Gradually moving force on the blank, so that the blank ultimately conforms to the whatever is the final shape. So what we have generally, the tool we have, which will apply, it will gradually move and apply force, okay. And in most of the cases, as we are talking of this particular sheet metal, which is generally thickness is small, and if we apply excessive force, it will be wet. So generally it is tasked with a this roller. The tool is generally held at the end, generally a ruler is there, and finally what will happen, gradually will increase, go on, and it will conform to this particular shape, okay. So this hatch mark, it is the final shape. So if you look at this particular figure, it will be more evident. So here different stages, progressive stages in spinning of a sheet metal product has been shown. So what happens, we have this particular original blank of sheet metal, that is the workpiece, and this is the, we have the form stock, okay, form metal block. And if we do this particular process in maybe late also, then this block has to be attached in the headstock spindle, and this particular original blank, it will be held in the tailstock, okay. And we'll have this particular tool attached with a particular roller, and we are going to apply gradual movement with force. And at the final step, once the process is over, actually it will conform to this particular shape, which is the required shape. It is axisymmetric about this particular axis, if you look at. And here this dotted line, it basically shows the progressive steps. So what will happen when you spin this, actually, and we apply force here, so initially it will get bent here, and this will be the next stage, okay. Further if we move on, so this will be the shape, then next further it will be this part, it will conform to this shape, similarly it will conform to this shape, and at the end of the process, basically it will look like this. So here an actual process has been shown. So this is the sheet metal, and this is the form block that is there. So like we are actually making here in this particular process a metal reflector that has been shown, and you can see the operator is holding the tool, and this is the like the form block that we have finally and in this stage you can see actually how the sheet metal is getting this particular shape conforming to this particular block, correct. So this is fine. We can do this kind of stuff. Similarly, very big you can say this, actually not this, I what should be the English word for uh or you can say the tal. We like we play this, there is a musical instrument, right? Or in the you can say even in the while worshipping also, in kirtan also we use a this kind of ka, we call it like, okay. So what should be the English name for it? Anyone know it? The tongue. If you have two pieces of this kind of shape, okay, its shape is somewhat like this. Okay, we hold it here, that particular part. Okay, which is a generally in some this traditional thing. Okay, made from bell metal. So actually, it is not exactly bell. Okay, but that kind of shape is there. Two pieces of it. So we hold it like we strike them, and there is a particular sign that sound that forms. So by this process, that kind of the product also can be obtained. So anyone knows the proper English name for it? Anyone? Sometimes in different orchestra, it's like this.
Yeah, bronze.
And bronze is the metal. Okay, we're not talking about the bronze. Okay, we're talking about this particular ka, that means borka or like that we use. Okay, tal. We're talking about the tal. Tal বুলি ক'লে বুজি পোৱা?
Brass.
Yes, tal is the
Brass.
Assamese name for this instrument.
Yes, sir. Mixer, no. So brass niki, sir.
No. I am not talking about the metal. I am talking about the product. আমি যিটো তাল বজাই যায় আমাৰ তালক ইংলিছত কি বুলি কয়? Do you know it? Actually, I forgot the exact name for what will be the exact name for this tal. That is the instrument. Okay. তালক কি বুলি কয় ইংলিছত? তাল যে বজাই। You know na tal? Yes, that instrument generally which are present in namghar, etc. In your home, maybe. Are you getting my point? So it's bell like thing. Okay, so whatever. So
Yes,
that
sir.
kind of product also we can get. Okay. So I think those who have understood, they have got my point, and you also, I think, don't know the exact English name for it. Actually, it's not bell. What will happen? I have to look for it. Okay, whatever. So this is basically about spinning operation. Okay, so next thing we'll be discussing about the bending operation. So bending operation also you can just go through it. It's very easy. So what is bending operation? It refers to a operation of deforming a flat sheet around a straight axis where the neutral plane lie. Okay, basically we are going to bend it. So what basically happens in bending, you can from your strength of material knowledge also you already know. So that particular neutral plane and all, okay, we play with that. Okay, so if you just go through it, it will be very easy to understand. Next topic we'll be discussing is stress forming. So what is stress forming? So this processes are small processes. They are very easy process only. Okay, made up with work with this particular sheet metal. Okay, so there are multiple operations, so you just have to know it. Once you go through it, it's very easy. Okay, so now stress forming. So what basically happens, the main important thing that you must remember is, in the case of stress forming, the complete deformation is generally carried out in the plastic stage. Okay, that is very important in case of stress forming. So you must know that stress forming, the entire thing is basically going on. Okay, entire operation is going on in the plastic stage itself. Okay, so what basically we do, as we are talking of doing the entire process in plastic stage. So the material, it has to be first brought into the plastic state by stretching. So we stretch the material. Okay, we are talking about the sheet material right now, and hence as we do the initial stage itself is kind of stretching. So the name is stretch forming. Okay, it is material is first brought into plastic state by stretching. Now here you can see basically some hydraulic cylinder with joint is there. Okay, and stretch the material. Okay, so it has been plastically deformed, and after that what happens, we have to, like as we have discussed, so the seat will be held in jaws of the hydraulic cylinders, and we have to stretch it beyond elastic limit so as to obtain the plastic range. Okay, now after that, actually the whole process involves, and depending on whatever is the type of shape that you require, so that kind of a separate die we have to use it, and that material is now made in contact with that kind of separate die. Okay, so as to give the shape of the die. So that is the main thing. And so if we have this particular die having this kind of shape, okay, this kind of concavity, so then at the end of it, basically the form of this particular sheet material, it will conform to the whatever is the shape that has been given in the die. Okay, so it's a very easy one only, simple process. Okay, and less expensive also, because we generally have only a single die. Okay, so but as you can very easily see, initially it has to be stretched and brought to the plastic range, and then we use the die and all. Okay, so actually it's limited by the complicacy of the shapes that we can obtain. So higher very complicated shapes it cannot be obtained. Okay, and another problem that is there, if suppose the final shape that you require, the final component, it has got hole in it. Okay, if we have to have the holes, then there is a chance, there is a possibility that in the stretch forming operation, the holes it may get enlarged. Okay, and one good thing also is there, this is one of the limitations. So as we are stretching it, so some of the physical properties it gets improved because of the uniform stretching. Okay, so next, the seats that we use in this particular forming, it has to be uniform in thickness. Otherwise, the thinner portions are like to be overstretched. That is another limitation. So uniform thickness it should be there. If somewhere, suppose if the metal is here, it is supposed thick. In this portion, suppose it is like somewhat thickness is less than thinner portion, it will be overstretched. So you will not final product, you will not be getting a uniform product. Okay, so that is basically about stretch forming. Understood? Yes, let me know whether you have understood or not. These are easy only. Okay.
Yes.
Okay. Next, we'll be discussing about this is basically about stress forming. So you can see a similar kind of thing has been described. So basically, form block, that is nothing but the die that we have. It has to be stretched initially, and after that, we use this particular form block to get this particular form. Okay. Next, okay, we have discussed that embossing and coining, these two process. I told you to go through it. Okay, but still will be so briefly it will be discussing. So embossing, basically, what is this embossing operation, which is frequently performed in the sheet metal? Maybe you have seen your this high security number plates. The numbers are like it is bulging out, that kind of thing, right? So you have seen, all of you have seen number plates of cars, bike, etc. Yes, it's a basically sheet metal on which the numbers are embossed. So what is this embossing? So basically what happens, this embossing is nothing but it's an operation which is used in making raised features. Raised means that's bulging out. Okay, raised feature on the sheet with its corresponding relief on the other side. That means in one side it is raised, okay, in the other side it is be corresponding shape relief will be there. Okay, so that is basically nothing but the embossing process. So you just go through the embossing process, what kind of clearance etc is required. So here the embossing has been shown. Basically what happens, the raised features from the sheet metal you are going to get, and corresponding relief will be there in the other side. Okay, so once again the die punch requirement will be there, and the shape but whatever you want to make, that kind of shape we have to have, and that is how it is being performed. So there is another similar, somewhat similar kind of operation is there, known as the coining. Okay, so what is this coining operation? So coining is generally as a considered as a coal forging operation. Okay, so what is the main important thing in case of coining? We make all, I believe all of you have already seen coins of different currencies, different nations, etc. There are some sometimes some symbols, some feature. Maybe if it is 1 rupee, then one is written or five or like that. And what you see, some like material is kind of, you get some shapes and all. Okay, maybe in the medal and all also you have seen. Okay, so sometimes the logo etc it is given. So that is nothing but those things are being done with the help of this coining process. Okay, but the thing that you must know is, generally in case of coining process, the flow of the metal, it occurs only at the top layers and not in the entire volume, and thus it corresponds if we have this particular die and punch arrangement. Okay, so generally this coining dies, it consists of a punch and die which are engraved with the necessary details required in both sides of the final object. And if we're talking about this coining process, the pressure is very high, and it's very like it easy. It's by this process it is we are able to give very intrinsic details in the detailing. Okay, and generally like decorative items, coins, etc., they are made by this particular coining process. I believe all of you have seen coins, all of you have seen medals, etc., where some symbols, some features, etc., are given. So basically they are made by this process known as the coining process. Okay, so then if you go through this particular problem, there is similar kind of problem just like we have discussed with respect to blanking size, punch size, etc., piercing size, etc. For both the cases, this kind of another problem has been shown here. You can just go through it. Is similar to the whatever we have discussed. And at the end, once again, this is very simple problem only. Okay, so that has been discussed where you have to find out the punching force, blanking force, etc., and you can just go through it. And with this, basically we have completed this particular portion of this particular module, and the whole module is over. So if you have any question you can ask me, and if you have understood you can let me know. So basically we have covered this thing. Okay, and the rest of the thing you can consider as an assignment, you can do that. whatever we have not discussed. Okay, some small portion. So any question, any doubt that you want to ask? Anything, anyone? Or if you have understood the things which are easy only, you can let me know whether you have understood or not. Okay, so I assume you have understood the things. Okay, so, okay, understood. Okay, thank you. So thank you everyone for joining this class. We are ending here. So thank you.
Thank you, sir.